Trigonometry, Chapter 6, Inverse Circular Functions and Trig Equations, Section 1, Inverse Circular Functions, Video 6, Composition of Trig and Inverse Trig Functions, Part 2. This series is based on content from Pearson's Trigonometry 12th edition by Lial, Hornsby, Schneider, and Daniels. In the previous video, we learned how to evaluate a trig function of an inverse trig function. In this video, we will learn how to evaluate the inverse trig function of a trig function. Sounds the same, except it's in reverse, and it's a different obstacle to overcome. For example, evaluate cosine inverse of cosine of 11 pi over 10. I can already tell what some of you are thinking. This looks easy. Inverse cosine and cosine cancel, right? Wrong. What? I thought that, no, it's a domain range issue. A function and its inverse cancel when the input is in the domain of the first and hence the range of the second. In other words, 11 pi over 10 is going into cosine, but needs to come out of cosine inverse if you're just going to say cancel these guys. But as part of a pair of inverse functions, the domain of cosine of x equals the range of cosine inverse of x, which equals 0 to pi. And since 11 pi over 10 is not between 0 and pi, it's impossible for 11 pi over 10 to be the output of cosine inverse. So no, these don't just cancel because this ratio will not come out of cosine inverse. It is not in the range of cosine inverse. So what do we do? Instead, we're going to view this through the lens of reference angles. First, how would we evaluate cosine of 11 pi over 10? Well, think about quadrants and think about reference angles. Since 11 pi over 2 is between pi and 3 pi over 2, it should be obvious that it's more than pi because 11 is more than 10. It's not as obvious that it's less than 3 pi over 2 unless you multiply both sides of this by 5. That makes it a 15 pi over 10. Then you can see it's in between. That means we're in quadrant 3. And if we were to draw an angle in quadrant 3, the value of cosine would be negative. That's important. Now, what's the reference angle? Well, the reference angle is 11 pi over 10 minus pi, which is the semicircle, leaving pi over 10 as the reference angle in quadrant 3. But which quadrant can cosine inverse give us values for? Well, the range of inverse cosine is quadrants 1 and 2, top two quadrants. And since we know cosine of pi over 10 is negative, then we need to go in a quadrant where cosine is negative, and that would be in quadrant 2. So we're going to take this reference angle from quadrant 3 and place it in quadrant 2, and then remeasure it. When measured from standard position, this angle is pi, semicircle, minus pi over 10, which is 9 pi over 10. So cosine inverse of cosine of 11 pi over 10 is 9 pi over 10. So they don't just cancel. Again, pi over 10, 11 pi over 10 is in quadrant 3. Cosine inverse can only give us values from quadrants 1 and 2. Since cosine of 11 pi over 10 would be negative based on the quadrant, then we need to go up to a quadrant for negative cosines when we're doing cosine inverse. That's why we put the reference angle in quadrant 2 and remeasured it and got 9 pi over 10. Let's try one more where the trig functions don't match, but we can find an exact angle. For example, cosine inverse of sine of negative 2 pi over 3. This is almost straightforward, especially if you have a unit circle, but you still have to know your quadrants. First, we're going to use the unit circle or reference angles in quadrants to get sine of negative 2 pi thirds is negative square root of 3 over 2. Now keep in mind on the unit circle or any circle, negative is backwards, so we have to go negative 2 pi over 3. So 2 pi over 3 is a sixth of a rotation. So here's 1, and then there's 2. That would put us down here. And the y coordinate is the sine. So sine of negative 2 pi over 3 is square root of 3 over 2. You could have also used an even odd identity. That sine of negative 2 pi over 3 is negative sine of 2 pi over 3. And at 2 pi over 3, sine is equal to square root of 3 over 2 with a negative. Now, to evaluate cosine inverse of negative square root of 3 over 2, note that the range of inverse cosine is 0 to pi, which means quadrants 1 and 2. Which angle in these quadrants has a cosine equal to negative square root of 3 over 2? Well, cosine is the x-coordinate. And it's right there. At 5 pi over 6, the x-coordinate is negative square root of 3 over 2. And hence, cosine of negative square root of 3 is pi over 6. That should say cosine inverse. That's going to bother me to no end. I thought I caught all the mistakes as I made them. In terms of leaving out inverses, this will not fly. That's a little bit better. And hence, cosine inverse of negative square root of 3 over 2 is 5 pi over 6. So if we put it all together, cosine inverse of sine of negative 2 pi thirds is the same as cosine inverse of negative square root of 3 over 2. We evaluate sine of negative 2 pi over 3. And then cosine inverse of that ended up being 5 pi over 6. As you can tell, we can just chase numbers around the unit circle sometimes. We started at negative 2 pi over 3. We found its sine. Pay attention to quadrants, because when we go into the inverse trig function, we have to pay attention that we're in quadrant 2. And we're doing cosine, so it's the x-coordinate, and then that brings us to 5 pi over 6. Now you try. Pause the video and try the following. No, on A, you can't just cancel the tangents. Here's your fair warning if you haven't paused the video yet. Solutions in 3, 2, and 1. For the first one, 3 pi over 2 is in quadrant 2 where tangent is negative. The reference angle is pi minus 3 pi over 2, which is 2 pi over 5. Try that again. The reference angle is pi minus 3 pi over 5, which is 2 pi over 5. The quadrant in the range of inverse tangent, where tangent is negative, is actually quadrant 4. So we place 2 pi over 5. We place 2 pi over 5 in quadrant 4 as a reference angle, measured from standard position, and get negative 2 pi over 5. B is a little bit more direct. Sine of negative pi over 4 is negative square root of 2 over 2. And so cosine of negative square root of 2 over 2 is 3 pi over 4 based on the quadrants in the range of cosine inverse.